This is example 2.3 on page 63 of your textbook. And here we're going to be looking at atomic numbers, mass numbers, and isotope symbols. So let's start by reviewing just really quickly what an isotope symbol looks like and what symbol stands for atomic number, what symbol stands for mass number. So in your textbook or in your PowerPoint slides, you should have a symbol that looks like this. This is technically a way to symbolize various elemental isotopes. And if you remember, an isotope is just an element that has a different number of neutrons. So every element has a specific atomic number, and that is represented with the letter Z. Seems a little backwards that it's not represented with A, but we won't get into that. So Z is atomic number, and it basically is the number of protons that are contained within the element. So that's written typically as a subscript to the left of the elemental symbol, and in this case we're saying that X is the elemental symbol. If I could spell element. So Z is atomic number, that's number of protons. And then another thing that's included in the isotope symbol is the mass number, and that's represented with the letter A. So the mass number for a particular element is its number of protons and number of neutrons. So it's protons plus neutrons. So basically, if you know one of these two numbers, you can always figure out the other. So we're going to do that in this problem. And we're also going to generate our own isotopic symbol. So A states, what are the atomic number, mass number, and symbol of the chlorine isotope with 18 neutrons? So we know, I'm going to draw a little line here. We know number of neutrons is 18, and we also know our elemental symbol is going to be Cl. We need to figure out number of protons, and we need to know what the two combined are so that we can figure out what our mass number is. So the most easy way to figure out our number of protons, our atomic number, is just to look at the periodic table. So we know we're dealing with chlorine. So if you go to a periodic table, typically the atomic number for the element you're looking at is written in either the right-hand top corner or above the element. So hopefully you have a periodic table handy. You can look at chlorine, which is on the far right side of the table, and it's got an atomic number of 17. So since it's got an atomic number of 17, that means it has 17 protons, because atomic number is number of protons. So our Z is 17. Now we need to figure out what our A is. Remember, A is mass number, and it's a combination of protons plus neutrons. So in this problem, it states that we have 18 neutrons. We figured out that we have 17 protons. So if we simply add the two together, we should get 35. So our mass number is 35. So now we can finally generate our isotope symbol. So we go back to this little guy right here. A goes on top, so it's going to be 35 on top. On the bottom is our Z, which is 17. And then off to the side is our element symbol, which is Cl. So that's part A. So I'm going to erase that. Hopefully you've got that down. So, and I'll write it off to the side here. Is 3517 Cl. So now for the second part, it says to figure out how many protons, neutrons, and electrons are present in an atom of 5224 Cr. So it's kind of like doing the opposite of what we just did. So we'll write that symbol down at the bottom, 5224 Cr. So right off the bat, we can figure out our number of protons. Remember, that's our number of protons. It's also known as the atomic number. So off to the side here, I'm going to say protons are equal to 24. Now, we haven't really talked about electrons in this example, but basically, until we start talking about ions, which are elements with different charges, either positive or negative, we're looking at elements that are neutral. So to be neutral, our positive and negative charges have to be equal. So that means electrons and protons are the same number. So number of protons is 24. That also means that number of electrons has to be 24. And then last, we need to figure out how many neutrons we have. If we remember that our mass number is written up top, it's also the number of protons plus neutrons. So if I know my number of protons and I know my mass number, I can subtract the two to figure out my number of neutrons. So 52 minus 24 gives me 28, which is equal to our number of neutrons. So in this second part of the problem, we have 24 protons, 24 electrons, because our atom is neutral, and 28 neutrons. And there you have it. That's isotopic symbols, atomic numbers, and mass numbers.